Hello, everybody, and welcome back. Root Beer here, and I'm looking at question 14. So we're almost at the halfway point in part B on our 2011 Fermat paper. Oh, gee, swallowed some air there. Which of the following must be an even integer? Okay, so it's not that there's a way to make one of these an even integer. It must be, no matter what we do, must be an even integer. So we've got some options. The average of two even integers. Okay, so is there a way to guarantee that that's going to be even? Or is there a way that I can make the average of two even integers odd? And for something like this, you might just want to play around with it a little bit. Okay? So, pick two even numbers. How about 2 and 4? Well, that would add up to 6. The average of those would then be 3, so that fails pretty quickly. Let's consider our other options. So we definitely know it's not A. B, the average of two prime numbers. Well, that certainly I don't think is going to work out, because I can think of two prime numbers really quickly, 2 and 3, and the average of those would be 2.5. That's not even an integer, so it's no way it's going to be even. But even if I wanted to specifically talk about integers, you could take 7 and 3. Those are both primes. And then that would be 10 over 2, and that would be an average of 5. Which, again, doesn't work because it's an odd. It's not that you can't make them even. 3 and 5 would give you an even average. It's just that they're asking which of these always is even. So all we have to do to show that this isn't the answer, all we have to do to show A or B isn't the answer, is to find at least one situation where the conditions are satisfied, but you don't get an even number in the end. Okay? C, the average of two perfect squares. Well, again, you could sort of just pick 1 and 4, and that'll be not even an integer. So again, that really fails. You don't want to do that. Do 1 and 9, and that'll still be 5 from before. It's not that hard for me to sort of be thinking of these. I don't have a sheet here that I'm working off or anything. I'm just sort of thinking of ideas in my head, ways to make this work. So we can move on to D. The average of two multiples of 4. Now, this will always be an integer. I'll get to that in a moment. E. The average of 3 consecutive integers. So this time we're dealing with 3 numbers. And there's a nice little trick for the average of 3 consecutive integers. It's always the middle number. And so those are consecutive integers divided by 3. It'll be 6 over 3, that's 2. Well, that is even, but if I did 2, 3, and 4 as my consecutive integers, the average there is going to be 3, and that's not even. So by process of elimination, I know the answer is D. But why did I know that D was going to be the answer as soon as I read it? Well, think about multiples of 4. 4A is a multiple of 4. 4B is a multiple of 4. I'm assuming A and B are integers. The average of these two, well, you add them up, divide by 2. You guys know how to calculate averages. So we'll get a 4a plus b on top divided by 2. Now 4 divided by 2 is just 2. Okay? Now a and b were integers, so this is 2 times an integer. This has to be even all the time. I don't even need to pick an a or a b. This is guaranteed to work. As long as you got 2 multiples of 4, average is going to be even. Because with the multiple of 4, you definitely get sort of an extra factor of 2 lying around, and that makes the numbers even. All right, so our answer there is going to be D. Fantastic question. Hopefully question 15 will be equally as interesting, but we'll find out about that in the next video, won't we? I'll see you there.